Hello viewers, in today's session we are going to discuss some important concepts from logarithms of complex quantities, right? And here we'll also see the meaning of principal and general value of logarithm of a complex number, right? So let us start and let us start with the function f of z, that is equal to e raised to z, right, where this z is a complex number. Say z is equal to x plus iota y, right? And let us take this function f of z as w, where w is again a complex number, and w can be written as u plus iota v, right? So here x is the real part of z and y is the imaginary part of z, and similarly u is the real part of w and v is the imaginary part of w. So now let us define the logarithm of this complex number, that is w, right? So w is equal to e raised to z, and if we take the logarithm of both sides, and here the base of the logarithm is the exponential number, right? So here we can write log w to the base e, and here we have log of e raised to z, and here we have the exponential number as base, right? So we can write log w is equal to z log e, and here we have also e. Now logarithm of e to the base e is 1, that is log e is 1. So here we can write z times 1, that is equal to z, right? So the logarithm of this complex number w is equal to z, right? So we have now the definition of logarithm of w. So now consider this expression, that is e raised to z plus 2n pi iota, right? And here this n is either 0 or a positive or negative integer. Now e raised to z plus 2n pi iota can be written as e raised to z times e raised to 2n pi I, right? So we have e raised to z, and e raised to 2n pi iota can be written as cos 2n pi plus iota sine 2n pi, right? Using Euler's definition, that is e raised to I theta is cos theta plus I sine theta. So now cos 2n pi is equal to 1, that is positive 1, and sine 2n pi is equal to 0, right? So we can now write e raised to z, and here cos 2n pi is equal to 1, and sine 2n pi is 0, right? Because here we have an integral multiple of pi, because n is a positive or negative integer, or n is 0, right? So sine 2n pi is equal to 0. So now this expression is equal to e raised to z times 1. This quantity is 0, so we have now e raised to z. So now we see that e raised to z plus 2n pi iota is equal to e raised to z. So it implies that when we replace z by z plus 2n pi I, then the function, that is f of z is equal to e raised to z, it remains unchanged, right? That is f of z plus 2n pi iota is also equal to f of z, right? So now if we replace this z by z plus 2n pi iota, then we have log of w is equal to z plus 2n pi I, where this n is either a 0 or a positive integer or a negative integer. So now this is an important equation, right? So it defines the logarithm of this complex quantity, that is w, which is u plus iota v. And here z is again another complex number, that is x plus iy, and here we have the additional term, that is 2n pi iota, right? So the logarithm of a complex quantity w is defined by this equation, that is z plus 2n pi iota, right? Now here we are going to now define two types of logarithms of complex quantities. That is, the first one is the general logarithm, and the second is the principal value of the logarithm of a complex quantity. So now let us define the general value of logarithm of a complex quantity and principal value of logarithm of a complex quantity, right? See, we have just seen the logarithm of w is equal to z plus 2n pi I, right? And here this n is either 0 or a positive or negative integer. And from this equation we can see that the logarithm of a complex quantity is a many valued function, right? So here the logarithm of a complex quantity has an infinite number of values, right? So when we take n is equal to 0, right? So this is an important concept. So when we take n is equal to 0 in this equation, then the logarithm of w is known as the principal value of logarithm of a complex quantity, right? So when we take n is equal to 0 in this equation, then we have log of w is equal to simply z, right? So this quantity is 0 when we take n is equal to 0, right? And for all other values of n except n is equal to 0, the logarithm of w is defined as the general value of logarithm of a complex quantity, right? So when n is equal to 0, then the logarithm of w is known as the principal value, right? And when n is any other positive or negative integer except 0, then the logarithm of w is known as the general value, right? So the general value of the complex number w is denoted by the capital letter L, right? So now we can write the general value of logarithm of this complex quantity w as capital L, and here we have log, and here we write w, here we have the base e, and we can now write z plus 2n pi I, right? And we have just seen that when n is equal to 0, then this z is equal to log of w. And here it is important to note that we have the small l, right? So when we use the small l in defining the logarithm, then the logarithm is known as the principal value, right? And when we take the capital L in defining the logarithm, then this capital L signifies the general value, right? So this replacing this z by log of w, we can now define the general value of logarithm of w as log w, and here we have the small l. So we have log w, and here we have the base e plus 2n pi I. So the general value of logarithm of a complex quantity w is defined by this equation. So now this equation can also be written as a log, and here we have the capital L, and w can be written as u plus iota v, and here we have a small l, and here we have log of u plus iota v, and 2n pi I, right? So remember, when n is equal to 0, then the logarithm of w is known as the principal value, and when n is any integer other than 0, then the logarithm of w is known as the general value, right? And from this equation we can see that since n can take any integer, so the general value of logarithm of this complex quantity is a many valued function. So the logarithm of w takes an infinite number of values. So now let us understand the concept of general value and principal value of logarithm of a complex quantity with the help of this example. So here we have to find a log of minus 3. So if we compare this one and this one, then we can see that w is equal to minus 3, right? So let us substitute w is equal to minus 3 in this expression. So we have a log of minus 3, and remember here we have the capital L, that is denoting the general value, and here we have the small l. So we have here a minus 3, and then we have 2 and pi I, right? Now see, minus 3 can be written as r e raised to I theta, right? So let us express this negative 3 as a complex number. So in the form that is r cos theta plus iota sine theta, right? And here we can write minus 3 plus iota times 0, and here we have r cos theta plus I r sine theta. So comparing the real and imaginary parts on both sides, we have r cos theta is equal to minus 3 and r sine theta is equal to 0, right? And we know that if we take the square of both sides in these two equations and adding the equations, we have r square cos square theta plus sine square theta is equal to minus 3 square plus 0 square. So we have now r square times 1, because cos square theta plus sine square theta is equal to 1, and here we have 9, and r square is equal to 9, and r is equal to 3, right? And taking this r is equal to 3 in this equation, we have 3 cos theta is equal to minus 3, that is cos theta is minus 3 over 3, that is minus 1, and cosine theta is equal to minus 1 implies that theta is equal to pi, right? So now taking theta is equal to pi in this equation, so we can now write minus 3 is equal to r times e raised to I theta. So r is 3, and here we have e raised to I pi, right? So now minus 3 can be written like this: 3 times e raised to iota pi, and let us substitute minus 3 is equal to 3 times e raised to I pi. So now we have the logarithm of minus 3 is equal to a log, and here we have 3 times e raised to I pi, and then we have 2n pi iota, right? So let us now simplify this expression. So applying the rules of logarithm, that is the product rule, we can now write log of 3 plus a log of e raised to I pi, and then we have 2n pi I. So now we can write log of 3, and here we can use the power rule, taking I pi in front of log, and we have log of e and 2n pi iota. So now we have log of 3, and log of e to the base e is 1, so we have simply I pi and here we have 2n pi I. So now we can write a log of minus 3 is equal to log of 3, and then we have here I pi common in these two terms, so we have 1 plus 2n, right? And where this n is either 0 or any positive or negative integer. And remember, we have just said that for n is equal to 0, the logarithm of minus 3 is known as the principal value, right? So this denotes the general value, and for n is equal to 0, we have the principal value, and the principal value is denoted by the small l. So we have log of minus 3 is equal to a log of 3, and taking n is equal to 0, over here we have I pi times 1 plus 2 times 0. So we have a log of minus 3 is equal to log of 3 plus, and this is 0, 1 plus 0 is 1, and here we have simply I pi, right? So viewers, this expression gives us the general value of the logarithm of negative 3, and this expression corresponding to n is equal to 0 gives us the principal value of negative 3. So let us quickly revise what we have done in this example. We have to find log of minus 3, and we have expressed minus 3 in terms of polar form, that is r e raised to I theta, and then we got the two equations, and we find r is equal to 3 and theta is equal to pi. Because theta is equal to pi, it satisfies both the equations. Cos theta is equal to minus 1 and sine theta is equal to 0, right? So whenever we have to find out expressions of this kind, then we have to first express this complex number or w in terms of polar form, and we get the value of r and theta, and then we proceed as per this equation. So now let us take one more example, and here we have to find the value of log of iota, right? So let us compare this expression with this one. Then the value of w is equal to I, right? And I can be written as 0 plus 1 times I. So let us express this complex number I in polar form. So I can be written as 1, that is 0 plus 1 I is equal to r e raised to I theta. And we can now write r cos theta plus I sine theta, and then we have r cos theta plus I r sine theta. So let us compare both sides. The real part is r cos theta is equal to 0, and here we have r sine theta that is equal to 1, right? So again, squaring both sides of these two equations and adding, we have r square, then we have cos square theta plus sine square theta is equal to 0 square plus 1 square. So this is 1, so we have r square times 1, and this is 0 plus 1, that is 1, so r square is 1 and r is equal to 1, right? So let us substitute r is equal to 1 in this equation, or in these two equations. We have 1 cos theta is equal to 0, and here we have 1 sine theta is equal to 1, right? So from here we have cos theta is equal to 0, from here we have sine theta is equal to 1. Now the value of theta, that is the common value which satisfies both these equations, is theta is equal to pi by 2, right? So here theta is equal to pi by 2 and r is equal to 1. We can now express the complex number I as r e raised to I theta. So r is 1. We have e raised to I pi over 2, that is e raised to I pi over 2. So now the value of log of I can be obtained from this equation. So now we can write log of I is equal to log of I, and then we have 2n pi I, and taking I is equal to e raised to I pi by 2. Here we have log and e raised to I pi by 2. Then here we have 2n pi I, and again using the laws of exponents, we can write I pi by 2, and here we have log of e to the base e and 2n pi I, and log of e to the base e is 1, and here we have simply I pi by 2 plus 2n pi I, right? And taking pi I common, we can now write pi I, and here we have a half plus 2n, right? So the general value of logarithm of I is given by this expression, right? And if we take n is equal to 0, then we have the principal value of I, that is the logarithm of I. So we can now write log of I is equal to, here we have n is equal to 0. So we can now write pi I half plus 2 times 0. So we have pi I times this is 0, so we have simply half, and this is pi I over 2, right? So viewers, the general value of the logarithm of iota is given by pi I times half plus 2n, and the principal value of the logarithm of iota is given by pi I over 2, corresponding to n is equal to